There is no table in the National Electrical Code that lists typical gains and take-ups for 90-degree conduit bends. The gains and take-ups are general guidelines used by electricians to estimate the additional length of conduit needed to account for the bend radius when installing 90-degree bends. These values may vary depending on the type of conduit, the bend radius, and the installation method. Gain is the increase in conduit length required to form the bend, while take-up is the decrease in conduit length due to the bend. Here are some general guidelines. For a 1/2 inch conduit size, the gain is typically 2 to 3 inches, and the take-up is 1/2 to 1 inch. For a 3/4 inch conduit size, the gain is typically 2 to 4 inches, and the take-up is 1/2 to 1 and 1/2 inches. For a 1 inch conduit size, the gain is typically 3 to 5 inches, and the take-up is 1 to 2 inches. For a 1 and 1/4 inch conduit size, the gain is typically 4 to 6 inches, and the take-up is 1 and 1/2 to 2 and 1/2 inches. For a 1 and 1/2 inch conduit size, the gain is typically 5 to 7 inches, and the take-up is 2 to 3 inches. For a 2 inch conduit size, the gain is typically 6 to 8 inches, and the take-up is 2 and 1/2 to 3 and 1/2 inches. While the table is not an official National Electrical Code standard, it can be a useful reference for electricians to estimate the approximate length of conduit needed for a 90-degree bend. It can help avoid purchasing excessive conduit or cutting conduit too short. However, it's important to note that these are just guidelines. Actual gains and take-up should be determined based on the specific project requirements and installation conditions. When bending conduit, several factors influence the accuracy and efficiency of the process. These factors include the type of conduit being bent, the bending equipment used, and the specific bending techniques employed. Different types of conduit, such as electrical metallic tubing, intermediate metallic conduit, rigid metallic conduit, and electrical non-metallic tubing, each have unique properties that affect their bending characteristics. For instance, electrical metallic tubing is typically easier to bend than rigid metallic conduit due to its thinner walls. The bending equipment used, such as hand benders, mechanical benders, and hydraulic benders, also plays a crucial role. Hand benders are suitable for smaller conduit sizes and smaller bending jobs, while mechanical and hydraulic benders are better suited for larger conduit sizes and more complex bends. Furthermore, the specific bending techniques used, such as stub-ups, offsets, and saddle bends, require different approaches and considerations. A stub-up involves bending the conduit at a 90-degree angle to bring it up from a surface, while an offset involves creating two bends to move the conduit parallel to its original path. A saddle bend involves creating 4 bends to navigate an obstruction. To ensure accurate conduit bends, it's essential to consider several factors. Firstly, the conduit must be properly measured and marked to indicate the desired bending locations. Accurate measurements are crucial for achieving the correct bend angles on the overall conduit length. Secondly, the bending equipment must be properly calibrated and maintained. A well-maintained bender ensures consistent and accurate bends. Thirdly, the bending process must be performed carefully and precisely. Applying consistent pressure and avoiding sudden movements can help prevent kinks and distortions in the conduit. Additionally, it's important to use the appropriate bending techniques for the specific type of bend being made. For example, when creating an offset bend, the two bends must be equal in angle and distance to ensure that the conduit remains parallel to its original path. The National Electrical Code provides guidelines and regulations for conduit installations, including requirements for bending and supporting conduit. Section 344.22 of the National Electrical Code addresses the number of bends allowed in a conduit run, specifying that the number of bends between pull points, such as junction boxes or conduit bodies, should not exceed 360 degrees total. This limitation is intended to prevent excessive pulling forces and potential damage to conductors during installation. Section 352.24 of the National Electrical Code covers the bending of electrical non-metallic tubing, specifying that bends must be made so that the tubing is not damaged and the internal diameter is not effectively reduced. This requirement ensures that the conductors can be easily pulled through the tubing without encountering obstructions. Section 344.30 of the National Electrical Code addresses the support of rigid metallic conduit, specifying that conduit must be securely fastened in place to prevent movement or damage. The spacing between supports depends on the size and type of conduit, with smaller conduit requiring more frequent supports. In addition to the National Electrical Code requirements, local building codes and regulations may also apply to conduit installations. It's important to consult with local authorities and inspectors to ensure compliance with all applicable codes. Furthermore, industry standards and best practices can provide additional guidance on proper conduit bending and installation techniques. Organizations such as the National Electrical Contractors Association and the International Association of Electrical Inspectors offer training programs and resources for electricians and inspectors. Proper conduit bending and installation techniques are essential for ensuring the safety and reliability of electrical systems. By following the National Electrical Code requirements, local building codes, and industry best practices, electricians can create conduit systems that are both functional and aesthetically pleasing. Accurate conduit bends minimize stress on conductors, reduce the risk of insulation damage, and facilitate easier wire pulling. A well-designed conduit system also enhances the overall appearance of the electrical installation, contributing to a professional and high-quality finish. In summary, understanding the principles of conduit bending, including gain and take-up, is crucial for electricians and anyone involved in electrical installations. By following the guidelines and regulations outlined in the National Electrical Code and adhering to industry best practices, it's possible to create conduit systems that meet the highest standards of safety and performance. Always prioritize safety when working with electrical systems and consult with qualified professionals when needed. The information provided here is for educational purposes only and should not be considered a substitute for professional advice. Always consult with a licensed electrician or qualified electrical contractor for any electrical work or installations.